Assalamualaikum. Here I'm going to present about my topic, which is socio-economic determinants of life expectancy at birth, which means the factors that affect the life expectancy at birth: food production index, carbon dioxide emission, which is in kilowatt, and total fertility rate, which is total birth per woman. So first of all, I'm going to introduce myself. So my full name is Muhammad Fariz bin Fariz, and I'm just calling myself as Asyraf, and my matrix number 1212880, and I am from KSP. So next, this presentation consists of four chapters, which is the first one introduction, and the second one literature review, and then the third one is data description and methodology, and the fourth one finally is the results. And also we have consists of a discussion with four questions that we can discuss about the results. Alright, so the first of all, for introduction, what's life expectancy at birth? So it means that a critical indicator of the overall health and well-being of a population, serving as a barometer for the effectiveness of healthcare system, social policies, and economic condition within a given society. As nations strive to enhance the quality and duration of life for their citizens, understanding the socio-economic determinants that influence life expectancy becomes imperative. This research delves into the intricate interplay between life expectancy at birth and three key socio-economic factors, which is I mentioned at the topic, which is the food production index, carbon dioxide emissions in kilowatt, and finally total fertility rate. So traditionally, studies on life expectancy focus on healthcare. However, recent research acknowledged the need to consider socio-economic factors. So my chosen variables is are the food production index, carbon dioxide emissions, and the total fertility rate, which is represent key aspects of a nation's socio-economic landscape. So this study, based on 2020 data from 56 countries, aim to identify the main socio-economic factors affecting life expectancy. So we focused on food production, carbon dioxide emission, and fertility rates as potential indicators to improve life expectancy at birth. So the goal is to provide valuable insights into how socio-economic and demographic factors influence life expectancy at birth. So, which is suggesting ways to improve it. The upcoming chapters will develop into previous studies, which is describing our data, with my data and methodology, present results, and conclude my findings. So next we go to the research problem. So why we know the importance of factors like food production index, carbon dioxide emission, and the total fertility rate on life expectancy at birth, there's a gap in understanding their combined impact. So most exciting studies focus on individual relationships, missing the complex connections between these factors. This research aims to fill that gap by using advanced econometric technique to analyze how these factors, which is both individually and collectively, influence life expectancy at birth. So the main question we are addressing is how do variation in food production index, carbon dioxide emissions, and total fertility rate contribute to differences in life expectancy across nations? Answering this is crucial for making informed policy decisions, helping governments and international organizations design interventions that address all the socio-economic factors influencing population health. So, through rigorous analysis, this research aims to provide true understanding of the relationship between these socio-economic factors and life expectancy at birth. The insights gained can benefit public health, economic, and policy making. So next we go to the research objective. So the first objective is to which is the major objective of the present study, is to determine the socio-economic determinants of life expectancy at birth. And then the second objective is to analyze the relationship between food production index, carbon dioxide emissions, which is in kilowatt, and the total fertility rate, which is the birth per woman, with expectancy at birth, which is our dependent variable. And then the last research objective is to suggest different ways to improve life expectancy at birth. Alright, so the next one we go to the research hypothesis. So first equation, as you can see here in my slide, represent the model is jointly significant. And then the next one we can see the equation for the life food production index, which is has a significant impact on life expectancy at birth. And the impact of FPI, which is food production index, and LEB, which is our dependent variable, which is life expectancy at birth, is negative. And then we go to the equation for the carbon dioxide emission on life expectancy at birth is statistically significant. And the increase when increased carbon dioxide emission will increase the life expectancy at birth. So we move to the fertility rate. The equation of fertility rate has a negative significant relationship with life expectancy at birth. So as for fertility rate increases, the life expectancy at birth will decrease. Alright. So next we go to the literature review. So basically in this chapter, I review five article, which is I take from to make the idea for this study. So basically, the first article is about the increase in life expectancy at birth over the last 2 centuries in developed countries. Is a notable achievement. Life expectancy at birth, the average lifespan, is a crucial indicator of a country's well-being and health, encompassing physical, mental, and social aspects. Recognized by the World Health Organization, which is WHO, as a key metric. It goes beyond a mere statistic, offering insights into the impact of government policies, cultural patterns, and individual behavior. Life expectancy's implication extend to various socio-economic aspects, which is influencing fertility rates, consumer spending, human capital investment, pension expenditure, public finances, and economic growth. So this literature review of this article underscores the significance of life expectancy as a comprehensive metric intertwined with various economic and social dimensions, which is setting the stage for an econometric exploration of these relationships. So the next article is about the expectancy at birth is intricately linked to the economic and social development levels of both developed and developing nations. So this study focus on investigating the socio-economic determinants influencing life expectancy at birth in Iran from 1985 to 2013. So, utilizing time series analysis, the research examines the impact of key factors such as GDP per capita, doctors per 10,000 population, uh, urbanization, food availability, carbon dioxide emission, total fertility rate, inflation rate, and literacy rate on life expectancy at birth. So the data were sourced from the Central Bank of Iran, Iranian Statistical Center, and World Bank. And then for this literature review of this article aims to contribute to the econometric understanding of the relationship between the socio-economic factors and life expectancy at birth. So, which is offering insights for policymakers to improve health outcomes in Iran. So as for the next article, this article study focuses on understanding the changing patterns of the total fertility rate across countries and delving into the factors influencing it. Unlike previous research, they address the limitation by considering time lag and cumulative effects in exploring the associations between influencing factors and TVR. They utilize the national level data from the World Bank data and United Nations Development Programme, employing distributed lag non-linear models with a 5-year lag to analyze these associations. The study contributes to the econometric literature by incorporating time lag and cumulative effects in understanding the intricate relationship between influencing factors and total fertility rate. As for the next article, the study explores the determinants of life expectancy in 31 of the world's most polluted countries, focusing on environmental degradation. The research employs the Preston curve model, utilizing panel-corrected standard errors and feasible general least square estimates for long-term effects. The study emphasizes that environmental degradation poses a threat to life expectancy in the examined countries. Recommendations include adopting policies to reduce carbon emissions, incorporating environmentally friendly technologies, increasing healthcare expenditure, and ensuring access to clean water and sanitation facilities for all. As for the last article, these study scholars have proposed input and output models focusing on the health status of a population, identifying variables such as life expectancy at birth, life expectancy at 65 years, a healthy life expectancy for the total population, and mortality indicators as good proxies for health. So, health expectancy at birth is the most widely used dependent variable, influenced by factors such as metabolic disorders, cardiovascular disease, cancer propensity, respiratory disease, lifestyle behaviors, working conditions, environmental factors, and social support. Okay. So next we move to the next chapter, which is data description and methodology. So as you can see the equation here, which is LEB for expectancy at birth, which is our dependent variable in this study, and then my independent variables. They have three factors, which is the first one log of food production index, and the second one log of carbon dioxide emission, and then the third one is total fertility rate. So to explain the context of this study is LEB, which is expectancy at birth, represent the average number of years a newborn is expected to live, which is providing a comprehensive measure of a population's overall health and well-being. Okay, for the independent variables, the first independent variable, which is log of food production index, it is an indicator of the agricultural productivity of a country. It measures the relative quantity of food produced per unit of agricultural land, which is providing insights into the efficiency and effectiveness of a nation's food production. This variable was transformed to logarithm value due to some reasons, which is to normalize the data so that the value of food production index become easier to compare and analyze in this study. Okay, for the next independent variable, which is log of carbon dioxide emissions. This refers to the amount of carbon dioxide released into the atmosphere, typically measured in kilotons. In this context, it serves as a proxy for environmental impact and pollution, reflecting the level of carbon emissions associated with a country's industrial and economic activities. This variable also was referred to logarithm, same reason like the first independent variable, which is to normalize the data so that the value is become easier to compare and analyze. And then the last independent variable, which is total fertility rate, which is to the represent the average number of children a woman is expected to have during her reproductive years. It is a key demographic indicator reflecting population growth trends and is influenced by factors such as family planning, social norms, and economic conditions. So why I do not transform it to logarithm like the first and the second independent variable, because the amount is already in the form of rate. So it can be used directly, and the value is already easier to compare and analyze in this study. So we move to the next chapter, which is the result, and then we go to the part of descriptive data in this study. So as you can see in the table, we can see for the life expectancy, the average and median are close, which is indicating a somewhat symmetric distribution. There's a slight leftward skew, and the range is substantial, suggesting variability. So, for the food production has also a symmetric distribution with a minor leftward skew and heavier tails. It has less variability compared to the life expectancy. As for the carbon dioxide emissions, in the table show a symmetric distribution with a minor rightward skew and lighter tails, which has higher variability compared to the life expectancy. And then for the fertility rates, have a potential rightward skew, heavier tails, and substantial variability. So, as from the data, in summary, we can see that life expectancy and food production index have relatively symmetric distributions, while for the carbon dioxide emissions and fertility rates exhibit some skewness. So, as for the carbon dioxide emissions and fertility rates, also show higher variability. So, this data diversity provides insights for econometric analysis. So for the next part in this chapter is correlation matrix. So as you can see here, this table shows the correlation for LEB, for population index, CO2, and also fertility rate. So we move to the table. The provided metric represent the correlation coefficient between the variables. The correlation coefficient range from -1 to 1, where 1 indicates a perfect positive correlation, -1 indicates a perfect negative correlation, and 0 indicates there's no correlation. Okay, so there are a lot of sample correlation as you can see here in the table between the variable. One of them is the correlation between LEB and the LFPI, which is the correlation coefficient by approximately is 0.49 0.4638, which is indicating a moderate negative correlation. And then besides the correlation between LEB and LCO2, which is the correlation coefficient by approximately is 0.4197, which indicate a moderate positive correlation. However, the last correlation between LEB and fertility rate (TFR), which is the correlation coefficient by approximately is negative 0.86014. 0.86104. 6014. So which is indicating a strong negative correlation. So for correlation between each independent variables, we can see that correlation between LFPI and LCO2, which is the correlation coefficient by approximately is negative 0.0214, which is indicating a very weak negative correlation. But correlation between LFPI and TFR, which is the correlation coefficient by approximately is 0.43023, which is indicating a moderate positive correlation. However, the correlation between LCO2 and TFR, which is the correlation coefficient by approximately is negative 0.305556, which is indicating a moderate negative correlation. So this correlation coefficient provide insights into the linear relationships between the variables. For instance, a negative correlation between life expectancy and TFR suggests that as one variable increases, the other tend to decrease, and vice versa. It's important to note that correlation does not imply causation, and other factors may influence these relationships. However, as for variance inflation factors, which is VIF, we can see for the first independent variable, which is the log of food production index, by approximately is 1.27. As for the second of independent variable, which is the LCO2, by approximately is 1.26. So as for the third independent variable, which is TFR, approximately is 3.84. If we look at the value of variance inflation factors VIF for each independent variable, which tell us how much the variance is inflected due to the multicollinearity, it shows that there are no multicollinearity exists, as the value VIF is moderate and less than 5. So as you can see here, this we move to the next part, which is regression analysis, which means coefficient interpretation and significance test result. So the first part for the regression analysis, we go through the simple regression. So as you can see here, as for the interpretation, the value of the intercept is 208.55. So, this value of the intercept, which is 208.55, estimated the value of LEB when LFPI is 0. So, as for the coefficient for the LFPI, which is by approximately is negative 29.08, this represents the estimated change in LEB at birth for 1 unit change in LFPI. In this case, for every 1 unit increases in LFPI, LEB is estimated to decrease by 29.08 units. The total number of observations used in the regression analysis is 56 countries, while for the value of R square is 21.51%, which is representing the proportion of the variance in the dependent variable, which is LEB, that is predictable from the independent variable, which is LFPI. In this case, simple regression for the first independent variable. In this case, approximately 21.51% of the variability in LEB is explained by LFPI. As for the sign of the slope coefficient of LFPI, the result is the same is as what I expected, which is negative by approximately the value is negative 29.08. The negative sign is in line with expectation, which is suggesting that there is a negative relationship between LFPI and LEB. As for LFPI increases, LEB is estimated to decrease based on this model. Therefore, the regression equation indicates that on average, higher values of LFPI are associated with lower LEB, which is life expectancy at birth. The negative sign of the LFPI coefficient aligns with the expectation, which is suggesting a negative impact on LEB as food production index increases. So we move to the next part for the regression analysis, which is we go through the multiple regression. So as you can see here, the data, this is the data which is indicates the multiple regression for all, which includes all the independent variables. And then the next slide, I will show you the my equation for this multiple regression. So as for the interpretation of the slope coefficient, the value of intercept is 180.06. This is the estimated value of LEB when all the independent variables are 0. As for the coefficient, which is beta 1 or slope, which is the LFPI, is negative 9.13. This represents the estimated change in LEB for a 1 unit change in the natural LFPI. So in this case, for every 1 unit increase in the LFPI, LEB is estimated to decrease by 9.13 units. So this terms of increase unit by unit or decrease by unit, you can see clearly in the next slide, which is I show you the equation for the this multiple regression as same slightly like a simple regression before. And then for the next as for the coefficient beta 2 or slope, which is the LCO2, but approximately is 0.74. This represents the estimated change in LEB for a 1 unit change in the natural LCO2. For every 1 unit increase in the LCO2, LEB is estimated to increase by 0.74 units. As for the coefficient beta 3 or slope, which is the total fertility rate, which is TFR, by approximately is negative 4.09. This represents the estimated change in LEB for a 1 unit change in TFR. For every 1 unit increase in the TFR, LEB is estimated to decrease by 4.09 units. So, as for the value of coefficient of determination, R squared, which is 0.7963, representing the proportion of the variance in the dependent variable, which is LEB, that is predictable from the independent variables, which is LFPI, LCO2, and TFR. In this case, approximately 79.63% of the variability in LEB is explained by the combination of the LFPI, LCO2, and TFR. Therefore, the MLR, which is multiple regression, equation provides insights into how changes in the independent variables are associated with changes in LEB. The negative sign of the coefficient for the LFPI and TFR suggests a negative impact on LEB, while the positive sign for the LLCO2 suggests a positive impact. So the next part in the chapter 4, which is discussion. So this is one of the most important in the study, where we can ask a question from the previous observation and the data. Okay, so one of the question that we can ask is, what happened to the slope coefficient, which is beta 1, once the model is MLR instead of SLR? So, and then discussed whether the model is suffering from omitted variable bias. So, in this case, the what happened is R squared increases significantly from 0.2151 in SLR to 0.7963 in an MLR. So the increases in R squared suggest that the MLR model explains a larger proportion of the variability in the dependent variable, which is life expectancy at birth, compared to the SLR model. In SLR model, the coefficient for LFPI is negative 29.08, indicating the estimated change in life, especially at birth, for a 1 unit change in LFPI. But in MLR, the coefficient for LFPI changes to negative 9.13. So, as for the interpretation, the MLR model provides a more comprehensive understanding of how LFPI, LCO2, and TFR jointly affect life expectancy at birth, capturing potential interaction and dependencies among these variables. So, for the next question in this part of discussion, state the null against one-sided and two-sided alternative hypothesis for all the variables and discuss whether all the any variables are statistically significant at all levels. Okay, so from this part, we can see from the data, regression and multiple regression. As for the null hypothesis HO of the coefficient beta 1 for LFPI is equal to 0, while the alternative hypothesis H1, which is two-sided of the coefficient for LFPI beta 1, is not equal to 0. One-sided left tail, which is for the coefficient beta 1 for LFPI, is less than 0, which is indicating a negative relationship. As for the null hypothesis of the beta 2 LCO2 is equal to 0, while the alternative hypothesis, which is two-sided of the coefficient beta 2, is not equal to 0, and one-sided, which is right tail for the coefficient beta 2 for LCO2 is greater than 0, which is indicating positive relationship. The transition from SLR to MLR result in a substantial increase in R square and a change in the LFPI coefficient, which is indicating a more nuanced and improved model that accounts for the influence of additional variable on LEB. So for this question also, as for the null hypothesis ratio of the coefficient beta 3, TFR is equal to 0, while the alternative hypothesis is which is two-sided of H3 of the coefficient beta 3 is not equal to 0, and one-sided which is left tail for the coefficient beta 3 which is TFR is less than 0, which is indicating negative relationship. In the CLR model, LFPI has a p-value of 0.00031799, which is indicating statistically significant at all conventional levels. But in the MLR model, LFPI remains statistically significant with a p-value of 0.04221177. But the next one, as for LCO2, LCO2 has a p-value of 0.001247291 in the MLR model, which is indicating statistically significant at all conventional levels, while for TFR has a very low p-value, which is 1.36056, and then multiple with negative, the power of negative uh, multiple with 10 the power of negative 13. And then in the MLR model, which is indicating strong statistically significant at all conventional levels. Therefore, in the both SLR and MLR model, LFPI, LCO2, and TFR are statistically significant at conventional significant levels. This suggests that all three independent variables have a significant impact. All right. So for the next question for this part is, what do you think if the independent variable together do a good job of explaining variation in the dependent variable and explain it? Okay. So uh, in this case, we can see in the term of the adjusted R squared is a measure of how well the independent variable explained in the dependent variable adjusted for the number of independent variables in the model. In this case, the adjusted R squared is 0.784534, and then which is indicating that approximately 78.45% of the total variation in LEB, which is explained by the independent variables, which is LFPI, LCO2, and TFR. And then for the next one, we can see in the term of significance of F statistic. The ANOVA table provides an F statistic, which is with a very low p-value, which is 5.66479 multiplied with 10 the power of negative 18, so which is essentially 0. This low p-value indicates that the very model overall model, which is including all the independent variable, is statistically significant. And then for the besides, we can see also in the term of individual coefficient. So each of the individual coefficient for LFPI, LCO2, and TFR has a low p-value, which is indicating that each variable makes a statistically significant contribution to explaining the variation in LEB. Other than that, is a standard error. The standard error of the model, which is 3.44023997, is relatively considered as low, which is suggesting that the model's prediction are on average, which is close to the actual observed values on of LEB. So, therefore, the combination of LFPI, LCO2, and TFR provides a statistically significant and effective explanatory power for the variation in life expectancy at birth. The adjusted R squared indicates that a substantial proportion of the variability in LEB is captured by these variables, and the overall F statistic supports the model's significance. So as for the last question for this part discussion, and the last of overall of this study is, do I need to add a quadratic function to the equation? So please justify. Okay, for to answer this question, adding a quadratic function to the equation might not be considered, except on several factors, which is such as the first one, theoretical justification. It is necessary if we want to consider whether there is any theoretical reason to expect as a quadratic relationship. If there's a priority knowledge or empirical evidence suggesting a non-linear association, adding a quadratic term may be justified. Besides, we can see also in the term of model complexity. Adding a quadratic term increases the model complexity. Evaluate the trade-off between model complexity and explanatory power. Avoid overfitting, where the model fits the noise in the data rather than the underlying pattern. Furthermore, we can also see in the term of statistical test, which is conduct statistical tests or information criteria such as AIC and BIC to compare the fit of the current model with a quadratic model. If the improvement fit is substantial and justified, adding a quadratic term might be reasonable. Therefore, from this study, the decision to add a quadratic function should be based on a combination of a statistical measure, which is like I mentioned before, theoretical and then and so on. But the current model adequately explain the variation in the dependent variable, and there is no evidence of a non-linear relationship, then in my opinion, adding a quadratic term may not be necessary for this study.